we are starting with the problem statement 725 lead code, which is of linked list. So let me first read the problem statement. So it is basically split linked list in parts. Given the head of a linked list, singly linked list, and an integer k, split the linked list into k consecutive linked list parts. The length of each part should be as equal as possible. No two parts should have a size differing by more than one. This may lead to some parts being null. The parts should be in order of occurrence in the input list, and parts occurring earlier should always have a size greater than or equal to parts occurring later. Okay, so basically what we have to do in this problem is we are given a linked list, singly linked list, the head of the singly linked list and an integer k, right? And we have to split this linked list into k consecutive linked list parts. So the partition should, after partition, that linked list parts must be consecutive, right? So we can't say that if this is the case 1 2 3, if I break this here and my second part of the linked list starts from here 7 8 9 10 and third one is 4 5 6, it must be consecutive, right? The second thing is the length of each part should be as equal as possible. So we need to make sure that the after partition the parts of each linked list have equal length almost, right? And no two parts should have size differing more. If we have some difference in their size, then it must be less than 2, right? It means either 0 or 1, right? So the part should be in the order of occurrence in the input list, and the part must be in the order, right? If we are breaking it, so if here and here, so it must be 1 2 and 3. It not be 1 3 2 or 3 2 1, right? So this is the requirement of this question, and after that we have to return an array of k part, right? So it means we have, let this is the, you can say, function. We have to return this, right? So vector of list node pointer, right? Okay, so let me show with the example. So if you carefully observe here, we have two conditions in this, right? Either there must be a case where k is greater than the length of the linked list given, right? Or the second case where your k is less than to the, you can say, length of a linked list, right? Either k is less than length or k is greater than length, or one or more cases k equal length of the linked list, right? So we if we carefully observe here, when k is greater than the length of a linked list, so what we are doing is we are breaking it individually, like each in each part we have only one node, right? And after that we have remaining two more list node pointer which needs to be inserted in the answer vector, right? So in that case we will insert two null linked list, right? So this is the case, right? And if we have k is, you can say, less than, then in that case what we have to do is we will break it. We can break it over here, but you saw that this, after breaking here, this part has only one node, right? And which will fail the condition of the uh, one of the requirement of this question is the any two part length of their difference must be less than, you can say, it will not be differ much by 1, right? So what we can do is In this case, what we can do is, first of all, we will find the length of this linked list, right? 10 here in this case. So what we will do is, we will divide this length divided by this k value. So we will figure out that in each part there must be that number of particular nodes, right? And that in this case 10 divided by 3 is 3 point something, in integer it almost 3. So in each part there must be 3 nodes present, right? And additionally, how much additional nodes are there? So we have to, if equipped with that node in one of the part, but the condition is we have to put extra nodes always from the starting point, the starting part. Like if we breaking over here and over here and we have extra nodes, so we will connect it from the in the first part of the linked list. Then if we have one more extra node, then we will connect in the second partition, and so on. So we will start with the first partition, right? So what we can do is, we will find the extra nodes, which in this case we have extra node only one, right? So 10, if we divide the length, sorry, if we do len modulo 3 or len modulo k, we will find the extra nodes, right? So 10 modulo 3 will give you a 1, so we have one extra nodes, right? So let's jump over the solution. So first of all, we have created a function find length, which nothing will it will return the length of the linked list, right? We initially pointed temp to head, temp is pointing to head, and then we will find the length of the linked list. Then after that we have make a vector of list node pointer, which is named as answer. Now what is the use of this? Next we will cover it in later section. Let me first jump over, we have two conditions, right? This and this. We can also do it like if length is less than equal to k. Then also what we are doing is, our temp is pointing to null, right? This is the case. So what we are doing, first of all, we will push that temp answer dot pushback temp, and after that we have to break this bound, right? So 1 is pointing to 2, we have to break it, and now 1 should be pointed to null. Then only we can say that we have partitioned the lecture, right? So what we are doing, we push the temp in the answer vector. After that we will use this next to store the next of the temp, so that when we will iterate to the next to the, you can say, further partition, so we will store it in next. So we next is storing the temp connect, and then we will break this temp connect equals null. After that temp pointed to next, so my temp is now pointing to this, right? After that again check the condition, temp is not equal to null, right? So what again, uh, answer dot pushback temp, which is now pointing to 2. After that again next is pointing to temp connect, which is 3, right? After that we will break this. We are breaking this because if we will not break, then we are pushing 1, right? But 1 is still pointing to 2, then it will not be singly 1. It will in first it will represent 1 2 3, then again if we push 2 it will represent 2 3, right? But we are supposed to do the partition, so that's why we are breaking this bond and doing this stuff. After that, if we have some extra like we have to add some extra partition, but since our node is no longer left. So what we can do is we will push that null linked list, right? So we calculate k minus len, which is the extra part which needs to be inserted in the answer vector. So we will find out this using storing k minus len into c, and while c is greater than 0 we will push that in the answer. After that we will decrement c minus minus, because we need to check either we will fulfill the condition or not, right? After that else condition, where length is greater than k. So in that case what we have to do is, first of all we need to find the mandatory number of nodes in each part, right? So how can we find this? We can find this using this length divided by k. So it will give to the mandatory nodes in each part. We have initialized part size equal length divided by k, and after that we have to find also how many number of extra nodes which need to be inserted, you can say greedily, from the starting partition, or you can say, and how many extra nodes are there which needs to be populated in the partition, so that we will fulfill the condition. So for that we have find using modulo operator len modulo k, it will find the extra nodes, right? After that we have initialize one variable current, which is initially 0, which will calculate till now how many nodes are inserted in that particular part, right? So while temp is not equal to null, we'll push first of all initially answer dot push back temp, we have inserted one. After that current, the size of the first part now will now become 1 because we have inserted one, right? After that we'll check while current is less than part size is 3, right? We need to pass at least 3 nodes in any part which we will find after partition, right? So after that we will also check the condition whether our temp is not going to null or so. If it pointed to null, then it will give rise to error, right? Runtime error. So what we will do, check the condition. After that our temp pointed to temp connect, which is my temp is now here, and my current also increment, like now we have 2 nodes in and the current part, right? After that again it will check 2 is less than 3 rest. So again we will no, our temp is not now pointing to this, and my current increment, now current will be 3, right? Now we'll check 3 is less than 3, no. So it will fail the condition. It will now check if is there any extra node which needs to be added in the current part. So we'll check if extra part is greater than 0, then simply we will iterate temp equal temp connect, which will point to now this, and extra part will be decrement, right? So now our first part will be completed. Now what we have to do is, now we will use see the use of next pointer. So our next pointer stores the address of 4 ka next, which is 5, right? And now my temp ka next, which is 4 ka next, will now points to null because we have to break this bound. After that my temp pointed to next, which is now my temp pointed to this, and again we have to put redeclare our current equals 0, not redeclare, we will assign current equals 0, right? After that it will again check well time temp is not equal to null, and so on. After that when while loop while temp reaches to null, it will come out of this loop and we will return this answer, right? Now submit this code, run. So it will hopefully run fine. Now we'll submit this solution. So yeah, it will work fine. So that's it for today. So I hope you understand this concept and the solution. If you find any difficulty in the solution or anything, you can comment it down. I be happy to like resolve your confusion or any doubt. So thank you.